Let's resume. Good afternoon, everybody. Let's resume. Now, before going into the break, we discussed that how is and what are the factors which are responsible for confinement of ozone layer in stratosphere when compared to troposphere. Then we discussed that ozone on account of its location can be both beneficial and harmful for mankind, that we have discussed. And the third thing that we were responsible for discussing was that how ozone depletion takes place, what are the ozone depleting substances, and what are brominated fire retardants, and what are the adverse impact of brominated fire retardants. But see, before going to the break, we started discussing the role of jet stream, which you have asked, is responsible for carrying the industrial emission to this particular area where the ozone depletion takes place. See, we have discussed just before moving into the break, and I repeat that industrialization is maximum in the tropical areas of northern hemisphere. Let me read. But depletion of ozone layer mainly takes place where? Mainly takes place in Antarctica. So the role of jet stream is what? It is responsible for carrying the ODSs for depletion of ozone layer. And in this area we can see, here we say in the tropical areas of northern hemisphere, industrialization is maximum. But if industrialization is maximum, it means that industrial emission would be more and more taking place in this area. But damage to ozone layer takes place in Antarctica. And I have discussed that before going into the breaks. When hot tropospheric air rises upward in this area, carrying the industrial emission, and industrial emission means that it has ODSs. ODSs means ozone depleting substances. Within it, it would be combining with the cold stratospheric air. And when it combines with the cold stratospheric air, it is responsible for pushing the emissions towards the poles. Clear? It is responsible for combining with cold stratospheric air, and this is responsible for formation of a circulation which is called as Dobson-Breuer circulation, which is responsible for pushing the emissions towards the poles. So emissions means that the ODS would be pushed towards the poles. Now, we can say that there are three factors which are responsible for ozone depletion in Antarctica. The first factor is what? The first factor is shape of the earth. The second factor is rotation of the earth. And the third factor responsible for depletion of ozone layer in Antarctica is lowest temperature of Antarctica. So there are three factors which are responsible. Now let's see how these three factors are responsible. Now we know that the shape of the earth is geoid. Geoid means that it is bulging out at the equatorial area and flattened at the poles. Now what happens that it is flattened at the poles. Now if suppose we take the center of gravity here, we can say that this distance is a short distance. This distance would be considered as a short distance when compared to this distance, or suppose this distance, or suppose this distance. Clear? So this would be considered as a short distance when compared to these distances. Now, since this is a short distance, what happens that when industrial emission, when Dobson-Buer circulation carrying the industrial emission reaches the polar area, it would be getting accumulated here. It is getting accumulated here. Accumulated in the polar areas because due to nearer center of gravity. See, the entire atmosphere of the earth is resting on the earth because of nearer center of gravity. The entire atmosphere of the earth is resting on earth due to nearer center of gravity. So what is happening? What is happening that when the Dobson-Buer circulation is responsible for carrying the industrial emission towards the poles, due to nearer center of gravity, this industrial emission is getting accumulated, which consists of ODS. Clear? Now, in this area, a localized wind pattern can be seen. See, in this area, a localized wind pattern can be seen. And this wind pattern is due to the rotation of Earth. Here also it can be seen. And here also near the South Pole also it can be seen. Now, this wind which blows in the polar area and is a cold wind is called as what? It is called as vortex wind. And this is due to the rotation of Earth. See, formation of polar stratospheric vortex is during winter, and that is another phenomenon we will discuss. But in this area, due to rotation of Earth, a localized wind phenomena can be seen in the polar areas, which is referred to as vortex wind. So the industrial emission which has reached here would be now, and which has carried the ODSs. So the ODSs which have got accumulated because of industrial emission reaching here would be now whirling along with the vortex, is now rotating along with the vortex. And when it rotates along with the vortex, nothing happens at that period of time. But after some time, when the winter comes, this vortex wind would be condensing, and this would be condensing to form a highly reactionary cloud, and this highly reactionary cloud is called as what? It is referred to as polar stratospheric cloud. This highly reactionary cloud is referred to as polar stratospheric cloud, PSC. Clear? So during winter, what will happen? That the vortex wind which is carrying the ODS, why? Because the Dobson-Buer circulation was responsible for, and Dobson-Buer circulation moves in the same area where the jet stream moves. So Dobson-Buer circulation would be responsible for carrying the industrial emission to this area, which consists of ODS, and this ODS would be now whirling along, rotating along with the vortex wind. Clear? Nothing happens. But when winter comes, the vortex wind, which consists of ODS, is condensing to form a highly reactionary cloud, and this highly reactionary cloud is called as what? It is referred to as polar stratospheric cloud. This highly reactionary cloud is called as polar stratospheric cloud, and this polar stratospheric cloud would be formed during winter, but nothing happens during winter also. No reaction takes place during winter. Why? Because for depletion of ozone layer, what is required are the two conditions. First is low temperature. Now you will say that low temperature is present in winter. What's wrong in that? But also with low temperature, the another factor which is required is solar radiation. Because to trigger ozone depletion reaction, solar radiation is a must. To kickstart ozone depletion reaction, solar radiation is a must. Clear? To kickstart ozone depletion reaction, solar radiation is a must. Fine. But solar radiation during winter in the polar areas happens to be missing. So nothing will happen during winter. No depletion takes place during winter. But when the winter gets over, and again, the solar radiation reaches this area. When the winter gets over, and again, the solar radiation reaches this area, it would be falling on the PSCs. And from the PSCs, from the PSEs, what will happen? That ODSs, ozone depleting substances, would be emitted. When the winter gets over, solar radiation reaches this area, it falls on the PSEs, and from the PSEs, ODSs would be released, ozone depleting substances would be released, which at this point of time would be responsible for maximum damage to ozone layer. Maximum damage to ozone layer. Why? Because it is a condition of low temperature, winter, which just the winter has got over. It's a condition of low temperature. And second, the solar radiation is present. To kickstart the ozone depletion reaction, the solar radiation is present. Clear? Solar radiation is present. Now this would be responsible for triggering ozone depletion reaction. So ozone depletion reaction would be triggered, and this depletion of ozone layer takes place on a larger scale. But see, why? There's one thing also which needs to be understood. When you talk about PSEs, if suppose this is your PSEs, inside the PSEs, there are thin sheets of ice, IG layers. We say that these are IG layers of PSEs. It is in these IG layers of PSEs that ODS is present. So when sunlight is falling on the PSEs, particularly on the PSEs, from the IG layers of PSEs, ODS would be released. ODSs would be released from the IG layers of PSEs. And these layers of PSEs would not only act as a source of ODS, but also platform, because this is ice, this is low temperature, but also platform for ozone depletion reaction to occur. So these layers of PSEs won't be only acting as a source, but also as a platform for ozone depletion reaction to occur. So when ozone depletion reaction occurs, when ozone depletion reaction is taking place, so it is acting as a platform for ozone depletion reaction to occur. And that's the reason why maximum damage would be taking place at this point of time. Maximum damage would be taking place at this point of time. Clear? At this point of time, maximum damage takes place. Is that clear? At this point of time. Now this you have to know, that why maximum damage takes place at this point of time. Clear? Fine. Maximum damage takes place at this point of time. This is the reason. And when you compare Arctic region, now if this be the case, then the similar type of damage should have taken place in Arctic region also. But there's a difference between Arctic region and Antarctica. In the Arctic region, the temperature during winter can dip down to -60, -70 degrees centigrade. The temperature during winter can dip down to -60, -70 degrees centigrade. In Antarctica, it can dip down to -115 degrees centigrade. It means what? That the IG layers of PSEs would be staying for a different period of, for a longer period of time in Antarctica when compared to the Arctic region, and damage to ozone layer would be more in Antarctica when compared to Arctic region. If suppose the temperature is more low, -115 degrees centigrade, it means that the IG layers here would be staying for a greater period of time in Antarctica when compared to the Arctic region, and damage to ozone layer in Antarctica would be more when compared to the Arctic region. Damage to ozone layer in Antarctica would be more when compared to the Arctic region. Clear? When compared to the Arctic region. Now, and we can see also that as far as formation of PSEs is concerned, formation of PSEs takes place at -76 degrees centigrade. Now this condition would be rendered by more conducively by Antarctica than compared to the Arctic region, because in Arctic region the temperature can reduce to -60, -70 degrees centigrade. Clear? Fine. So you can see there are three reasons for mainly damage of ozone layer in Antarctica. First is the shape of the earth. Second is what? Second is the rotation of earth, because it is responsible for formation of vortex. And third is the lowest temperature of Antarctica, so that the ice layers would be staying for a greater period of time. See, as far as the Coriolis force is concerned, we are not talking about the Coriolis force. I am talking about the Dobson-Buer circulation. Now, in this case, it's not the jet stream. It's the Dobson-Buer circulation which is responsible for pushing the emissions towards the poles. It's just like a convectional current which is formed at the tropopause, and this pushes the emission towards the poles. Now that does not have any linkage, but the only linkage that you can be drawn between jet stream and ozone layer depletion is what? That the jet stream can carry the industrial emission from one place to another. And the industrial emission are what? It consists of greenhouse gases, and all greenhouse gases are ODSs. So here you don't have to draw this linkage that there are six types of jet stream. How Coriolis force and 0 degree line allowed north subtropical jet stream in south tropical jet stream. That correlation needs not to be drawn here. But I am saying that when jet stream are responsible for carrying industrial emission from one place to another, it's not only that the westerly disturbances would be carried, but along with it sometimes the industrial emissions are also carried. So that is responsible for damage to the ozone layer. Clear? It's not that here we are talking about the jet stream. It is not jet stream. It's a Dobson-Buer circulation. Clear? It does not have any linkage with jet stream. But the jet stream would be responsible for carrying industrial emission from one place to another. Jet stream blows where? Jet stream blows in the mid-latitudinal area of northern and southern hemisphere. And sometimes jet stream can meander also. When jet stream meanders also, it can carry the industrial emission from one place to another. For example, meandering of jet stream is called as what? Rossby waves. So that would be also responsible for carrying the industrial emission from one place to another. So it can be carried by the jet stream in the upper strata of atmosphere. So, and we are referring only to industrial emission because industrial emission consists of ODSs. Here you don't have to draw the relationship between Coriolis force and jet stream. Clear? Write down please. Industrialization is maximum in the tropical areas of northern hemisphere. Industrialization is maximum in the tropical areas of northern hemisphere. Tropical areas of northern hemisphere. But damage to ozone layer, is maximum in Antarctica. But damage to ozone layer is maximum in Antarctica. Maximum in Antarctica. There are three factors responsible for it. Three factors responsible for it. First, shape of the earth. Second, rotation of earth. And third, lowest temperature of Antarctica. Shape of the earth, rotation of earth, and third, lowest temperature of Antarctica. Lowest temperature of Antarctica. Lowest temperature of Antarctica. Remember, when the hot tropospheric air in the tropical areas of northern hemisphere, when the hot tropospheric air in the tropical areas of northern hemisphere tropical areas of northern hemisphere. When the hot tropospheric air in the tropical areas of northern hemisphere mingles with the cold stratospheric air, mingles with the cold stratospheric air, mingles with the cold stratospheric air, Dobson-Breuer circulation is generated. Dobson-Breuer circulation is generated. Breuer circulation is generated, which is responsible for pushing the emissions. Dobson-Breuer circulation is generated, which is responsible for pushing the emissions. Towards the poles, which is responsible for pushing the emissions towards the poles. The industrial emissions get accumulated near the poles. The industrial emission gets accumulated near the poles, due to nearer center of gravity, and you can write in bracket shape of the earth, due to nearer center of gravity. See, the entire atmosphere of the earth is resting on earth. Why? Because of gravitational pull. So when this industrial emission reaches here, it would be accumulated over here or here due to nearer center of gravity. Clear? Due to nearer center of gravity. Nearer center of gravity. Industrial emission gets accumulated here due to nearer center gravity. Right on, due to rotation of earth in the polar areas, vortex wind is formed. Due to rotation of earth in the polar areas, vortex wind is formed. The industrial emission now whirls along with the vortex wind. The industrial emission now whirls along with the vortex wind. Industrial emission now whirls along with the vortex wind. Clear? And this is due to the rotation of the earth, that the formation of vortex wind is taking place here also, and it is taking place here also. And we can see that when winter comes, vortex wind would be condensing to form a highly reactionary cloud, which is called as PSCs, polar stratospheric cloud. Right on. When winter comes, the vortex wind condenses. When winter comes, the vortex wind condenses to form a highly reactionary cloud. Vortex wind condenses to form a highly reactionary cloud, which is referred to as condenses to form a highly reactionary cloud, which is referred to as polar stratospheric clouds, which is referred to as polar stratospheric, which is referred to as polar stratospheric cloud. Polar stratospheric cloud. Polar stratospheric cloud. Polar stratospheric cloud. That is called as PSCs. Fine. Now nothing will happen during winter. Why? Because for ozone depletion reaction to occur, there are two conditionalities required. Write down. No occurrence takes place during winter. No occurrence takes place during winter. occurrence takes place during winter. As for ozone depletion reaction to occur, as for ozone depletion reaction to occur, ozone depletion reaction to occur, there are two conditions required. There are two conditions required. Two conditions required. First, there are two conditions required. First, low temperature. Low temperature, that's the first thing which is required. And second thing, you know very well, we have discussed that to kickstart ozone depletion reaction, solar radiation is also a must. And in winter, solar radiation in polar areas is missing. Write down, to kickstart ozone depletion reaction, to kickstart ozone depletion reaction, kickstart ozone depletion reaction, solar radiation is a must. Solar radiation is a must. Radiation is a must. To kickstart ozone depletion reaction, solar radiation is a must. Radiation is a must. Clear? Solar radiation is a must. Radiation is a must. So first of all, these things should be considered. Two tip. And see, after the winter gets over, we can see, and solar radiation reaches this area, it falls on the PSEs, and from the PSEs, ODS would be released. After the winter gets over, after the winter gets over, and solar radiation reaches this area, after the winter gets over, and solar radiation reaches this area, solar radiation reaches this area, it falls on the PSEs, and solar radiation reaches this area, it falls on the PSEs, it falls on the PSEs, and from the PSEs, it falls on the PSEs, and from the PSEs, ODSs would be released, and from the PSEs, ODSs would be released. ODSs would be released, and from the PSEs, ODSs would be released. ODSs would be released, which would do maximum damage to ozone layer, which would do maximum damage to ozone layer, which would do maximum damage to ozone layer, maximum damage to ozone layer. Is that clear? And why maximum damage to ozone layer? Because maximum damage to ozone layer at this point of time, which would do maximum damage to ozone layer at this point of time. But then the question is why? How? See, the IG layers of PSEs, ODSs are present. The source of ODSs in PSEs happens to be the IG layers. And the IG layers of PSEs not only act as a source of ODS, but also a platform for ozone depletion reaction to occur. Write down, the IG layers of PSEs, the IG layers of PSEs not only act as, the IG layers of PSEs not only act as a source of ODS, not only act as a source of ODS, but also platform for, ozone depletion reaction to occur, but also a platform for, ozone depletion reaction to occur. The IG, I repeat, the IG layers of PSEs, not only act as a source of ODS, source of ODS, but also a platform for ozone depletion reaction to occur. And you can see the target is also present there. The target is ozone, which is present in the stratosphere. So the source is also present there. The target is also present there, and the condition is also present there. Clear? Then the question is, why Antarctica? Now compare Arctic and Antarctic region, because these things are suitable for Arctic region also. Right now, the temperature of Arctic region during winter, the temperature of Arctic region during winter, the temperature of Arctic region during winter can dip down to, the temperature of Arctic region during winter can dip down to minus 60 to minus 70 degrees centigrade. During winter can dip down to minus 60 or minus 70 degrees centigrade. Minus 70 degrees centigrade. But that in Antarctica can go down to minus 115 degrees centigrade. But that in Antarctica can go down to minus 115 degrees centigrade. Minus 115 degrees centigrade. Can go down to minus 115 degrees centigrade. Clear? So what does that imply? This is Arctic region and this is Antarctica. Now that implies that the icy layers of PSCs in this area would be staying for a greater period of time, and depletion of ozone layer in this area would be more when compared to the Arctic region. Right down as such, the icy layers of PSCs, in this area, the icy layers of PSCs in Antarctica would be staying for a greater period of time. As such, the icy layers of PSCs in Antarctica would be staying for a greater period of time. And damage to ozone layer in Antarctica. Antarctica would be more when compared to the Arctic region. More when compared to the Arctic region. Is that clear? Fine. Compared to the Arctic region. Fine. More when compared to the Arctic region. Fine. Now let's take up that. So minus 60, minus 70 degrees centigrade, and in Antarctica it can dip down to minus 115 degrees centigrade. So you can see that here the damage would be more because the icy layers would be staying for a greater period of time. But there's another factor, and what is that? That formation of PSCs takes place at minus 76 degrees centigrade. This condition would be rendered by Antarctica more when compared to Arctic region. Right on the formation of PSCs suitably takes place. At minus 76 degrees centigrade. Formation of PSCs suitably takes place at minus 76 degrees centigrade. This condition would be rendered by Antarctica more. When compared to the Arctic region. Fine. Compared to the Arctic region. Fine. Now this you have to know, and this is the reason. But see, we have to draw some connects based on contemporary issues. And one such connect is what? That if more of ozone layer depletion takes place, more of global warming also takes place. In the year 2021, there was a report published by Lancaster University. Lancaster University is present in UK. And this report says that global warming is connected to ozone layer depletion in more than one way. Global warming is connected to ozone layer depletion in more than one way. Now, what is the report and what is said by the report? Let's examine that. Clear? Now, the first thing is that there are three connects between global warming and ozone layer depletion drawn by the report. The first connect is what? That all ODSs are greenhouse gas. First connect, all ODSs are greenhouse gases. Clear? So, if suppose greenhouse gases are responsible for enhancing global warming, then certainly more and more ODS would be released. So, here we say first connect is what? That all ODSs are greenhouse gases also. So, more global warming, more ozone layer depletion. That's the first connect. The second connect is what? That the adverse impact of ozone layer depletion not only includes skin cancer and cataract. The adverse impact of ozone layer depletion also includes some other things. It also includes what? It also includes damage to immune system. It also includes damage to nucleic acid. It is also responsible for what? It is also responsible for damaging phytoplankton. So, photosynthesis performed by the phytoplanktons would be getting reduced. So, it damages the phytoplankton also. And as such, photosynthesis performed by phytoplankton would be getting reduced. Clear? So, that is done. And we can see that is done. So, if suppose photosynthesis performed by phytoplankton is reduced, then what will happen? Then the carbon sinks would be reduced. Carbon sinks means absorbers of carbons. So, the carbon sinks would be reduced. And if carbon sink is reduced, then certainly the level of CO2 in atmosphere would be enhancing. This would be further aggravating global warming. This would be further aggravating global warming. Now, that's one second connect. The third connect is what? It is said that due to global warming, the temperature of troposphere enhances, but that of the stratosphere is getting reduced. The temperature of troposphere is enhancing, but that of the stratosphere is getting reduced. And if the temperature of troposphere has enhanced and that of the stratosphere is getting reduced, now this would be responsible for what? Reduction in temperature of stratosphere is responsible for enhancing global warming in two ways. First, low temperature is conducive for what? Conducive for its depletion. We know that. And second is formation of PSEs takes place at minus 76 degrees centigrade. So, that can also be said. So, let's draw a connect between global warming and climate change. And that's why I said that if industrial emission is carried from one place to another, it means that ozone layer depletion would take place. Clear? Right on. According to a report published by Lancaster University. According to a report published by Lancaster University, UK, Lancaster University, UK, global warming is related to ozone layer depletion. Global warming is related to ozone layer depletion. Ozone layer depletion. In more than one way. Global warming is related to ozone layer depletion in more than one way. More than one way. There are 3 connects drawn in this report. There are 3 connects drawn in this report. 3 connects drawn in this report. Now the first connect is what? The first connect is that all greenhouse gases are ODSs also. All greenhouse gases are ODSs also. All greenhouse gases are ODSs also. What is the second connect? The second connect which is drawn is what? ODSs also. And the second connect is what? That due to ozone layer depletion, phytoplankton, photosynthesis performed by phytoplankton would be reduced because phytoplanktons would be damaged. And this reduces the carbon sink, which enhances the level of CO2 in atmosphere and further aggravates global warming. Write down, due to global warming, phytoplankton would get damaged. Phytoplankton would get damaged. Due to global warming, phytoplankton would get damaged. And photosynthesis performed by phytoplanktons would be reduced. Which reduces the carbon sink. And enhances the level of CO2 in atmosphere, which reduces carbon sink and enhances the level of CO2 in atmosphere. Further aggravating global warming. Aggravating means enhancing. Further aggravating global warming. Now that's the second connect drawn. And the third connect is what? First connect, second connect, and third connect. Third connect is what? That due to global warming, the temperature of troposphere is enhancing. Why? Because greenhouse gases are more present in troposphere and they are responsible for absorbing more and more of solar radiation. So greenhouse gases are more present in troposphere. They are responsible for absorbing more and more of infrared radiation. So more warming, the troposphere would be becoming more warmer, but the escape of infrared radiation into the stratosphere would be reduced. So it would be becoming what? It would be becoming more cooler. Clear? Because see, what happens? The solar radiation is responsible for directly heating the surface of the earth. And due to direct impact of solar radiation, temperature of an area is not determined in case of troposphere. So in case of troposphere, first of all, the solar radiation is responsible for striking the surface of the earth, and from the surface of the earth, the infrared radiation would be generated. Now these infrared radiation which is generated would be responsible for what? Radiation which is generated. These infrared radiation which is generated would be responsible for what? It would be absorbed by the greenhouse gases. A part of it is absorbed by the greenhouse gases, through which the temperature of earth gets moderated. But if excess level of greenhouse gases is present in atmosphere due to industrial emission, it means more and more of it is being absorbed by, more of infrared radiation is being absorbed by the greenhouse gases. And if more and more of infrared radiation is absorbed by the greenhouse gases, then the temperature of troposphere would be enhancing. But then the escape of, if more is absorbed here, it means that the escape of infrared radiation in stratosphere would be reduced. And this reduces the temperature of stratosphere. Temperature of stratosphere would be reduced because of this. Clear? So, we can see that if more global warming takes place, temperature of troposphere would enhance, but that of stratosphere would be reducing. And the reduction in temperature of stratosphere would be affecting global warming. The reduction of temperature in stratosphere would affect global warming. Ozone layer depletion, not global warming, ozone layer depletion in two ways. One is low temperature is conducive for its depletion, and second is formation of PSCs takes place at minus 76 degrees centigrade. Write down, due to global warming, third connect, due to global warming, the temperature of troposphere enhances. The temperature of troposphere enhances, but that of the stratosphere gets reduced. The temperature of troposphere enhances, but that of the stratosphere gets reduced. Reduction in temperature of stratosphere. Would affect ozone layer. Reduction in temperature of stratosphere would affect ozone layer in two ways. First, low temperature is conducive for its depletion. Temperature is conducive for its depletion. And second, low temperature is conducive for its depletion. And second, formation of PSCs takes place at minus 76 degrees centigrade. Formation of PSCs takes place at minus 76 degrees centigrade. So, that's the connect between global warming and climate change, that if more of global warming takes place, not climate change, more of ozone layer depletion would take place. Clear? Fine. See, during spring in Antarctica, suppose this is the Earth and this is Antarctica. During spring in Antarctica, the polar stratospheric air would be moving outward. So, when it moves outward, the nearby areas, they are responsible for issuing what is called as UV alert. The nearby areas are responsible for issuing UV alerts. And UV alert means what? That when the polar stratospheric air is moving outward, which is stratospheric air, where ozone layer is present. Clear? But polar stratospheric air is moving outward during spring in Antarctica. We can see that this period of time maximum damage to ozone layer takes place. Now, it means that this air has ozone depleted within it. Ozone is not a solidified layer that it should be staying at one place. Ozone is in a gaseous stage. So, when the polar stratospheric air is moving outward from Antarctica during spring, it has ozone depleted within it. And due to this, nearby countries are responsible for issuing what is called as UV alerts. On the other side, we can see that the countries which are nearer to the polar areas, they also maintain what is called as UV index. And UV index is nothing but a daily forecast of UV exposure. Daily forecast of UV exposure. Write down. During spring in southern hemisphere, now winter is over. Now during spring in southern hemisphere, the polar stratospheric air moves outward. The polar stratospheric air moves outward, which has ozone depleted within it, and as such the nearby countries, are responsible for issuing UV alerts. As such, the nearby countries are responsible for issuing UV alerts. It means that don't have to venture outside. There can be cases of skin cancer and cataract. So don't have to go outside. Clear? So that would be UV alerts would be given. Is that clear? Fine. UV alerts can be given. So that you have to remember that how UV alerts are given. Fine. Also we can see that the countries which are near the polar areas, whether Arctic region or Antarctic region, they are also responsible for maintaining what is called as UV index, a daily forecast of UV exposure. And you can plan your picnic schedule according to that UV index. Right? On the countries which are near the polar areas, maintain a daily forecast of UV exposure, called UV index. A daily forecast of UV exposure called UV index. So there are two terms. One is called as UV alerts and second is called as what? Second is called as UV index. UV index. Is that clear? Fine. It's called as UV index. Now see. Fine. Now see, let's talk about other things also. Now see, when you talk about the adverse impact of ozone layer depletion, the adverse impact of ozone layer depletion includes many. The adverse impact of ozone layer depletion includes many. Now, first adverse impact of ozone layer depletion is what? Skin cancer, cataract, damage to immune system, damage to nucleic acid. We have discussed that the photosynthesis performed by phytoplanktons would be reduced. And why photosynthesis performed by phytoplanktons would be reduced? Because phytoplanktons are damaged by the UVB radiation coming in abundance towards the earth. And not only this happens, but There are other adverse impact also. So in one line we can write the adverse impact of ozone layer depletion. But when we talk about the initiatives, that what initiatives have been taken till date, one initiative is in the year 1985 when ozone layer depletion was reported for the first time. In the same year we can see that an initiative was taken, and that initiative was called as what? That initiative was referred to as that initiative was referred to as what? That initiative was called as a Vienna Conference. So Vienna Conference was organized, and the purpose was to study the impact of anthropogenic activities in ozone layer depletion. So it was studied, and also asked the government of respective countries to take administrative and legislative measures for that purpose. Also asked the government of respective countries to take administrative and legislative measures for this purpose. Legislative measures for this purpose. Now that is what that is called as what? That is called as your the Vienna Conference. But concrete measures were taken in 1987 when Montreal Protocol was signed. Montreal Protocol was signed by 27 nations. So let's discuss all the initiatives which have been taken for ozone layer depletion. Write down the adverse impact of ozone layer depletion. The adverse impact of ozone layer depletion. Adverse impact of ozone layer depletion is not only the adverse impact of ozone layer depletion is not only skin cancer and cataract, is not only skin cancer and cataract, but also damage to immune system, damage to immune system, damage to nucleic acid, damage to immune system, damage to nucleic acid, damage to immune system, damage to nucleic acid, skin cancer and cataract, but damage to immune system, damage to nucleic acid, and photosynthesis performed by phytoplanktons, would get reduced. Photosynthesis performed by phytoplanktons would get reduced. Write down initiatives. Write down in 1985, when ozone layer depletion, when ozone layer depletion was reported for the first time, Vienna Conference was organized. Conference was organized. The purpose was to study the impact of anthropogenic activities. On ozone layer. And it also asked also asked the government of respective countries, and it also asked the government of respective countries, the government of respective countries, to take administrative, and legislative measures, for this purpose. Government of respective countries to take administrative and legislative measures for this purpose. Clear? It also asks the government of respective countries to take administrative and legislative measures for this purpose. Is that clear? Fine. But see, concrete steps were taken in 1987 only. And concrete steps were taken in the form of what is called as Montreal Protocol. So Montreal Protocol was signed by 27 nations in 1987. And the objective was to limit the production of ozone depleting substances. Not only that, but also to phase them out. So the objective was to limit the production of ozone depleting substances and also to phase them out. That was the objective. And in Montreal Protocol, we can see that the ODSs were classified, class 1 ODS, class 2 ODS. ODSs were classified and 2 time frames were set. One time frame was set for developed nation and second was for developing nations. So we can see there were 2 time frames set, one for developed nation and second for developing nation. And the purpose was very obvious: to phase out to remove the ODSs. But among the 27 nations which signed the Montreal Protocol initially, India was not present. India became a signatory to Montreal Protocol only later on. So we can see that India desisted to sign the Montreal Protocol earlier and was not among the 27 nations which signed it earlier because of 2 or 3 reasons. India believes in what is called as polluter pays principle. Polluter pays principle. India believes in what is called as ecological depth. And India believes in CBDR, that is common but differentiated responsibility. Differentiated responsibilities. So India believes in polluter pays principle, India believes in ecological depth, and India believes in CBDR, that is common but differentiated responsibility. Now, when you talk about polluter pays principle means what? It means that when you talk about developing nations say what? That they were never responsible for polluting the planet of Earth. They were never responsible for initially emitting so that the climate Earth is polluted. So they were not responsible for doing so. This was started by the developed nation. They were responsible for polluting the Earth. So if suppose initiatives have to be taken by the developing nation also now, the funding should come from the developed nation. So that's called as polluter pays principle. That those who were responsible for polluting the atmosphere of the earth should be responsible also for funding the initiative. So that's called as polluter pays principle. Second is called as ecological depth. Ecological depth means that developed nation under its colonial or imperial rule were responsible for what? Under its colonial or imperial rule were responsible for exploiting the resources of earth, and these resources were meant for all nations. So when they were responsible for exploiting the resources of earth, which was meant for all nations, what happened that today they have to pay it back to the developing nation. Now this principle is called as what? It's called as ecological depth. And the third is what? Third is called as CBDR. CBDR stands for common but differentiated responsibility. It means that suppose I am developing nation, you are developed nation. The objective of both developed nation and developing nation is the same. The objective of both developed nation and developing nation is the same. And what is the objective? The objective is to develop. Objective of both developed and developing nation is the same. And the objective is what? The objective is mainly to mitigate the adverse impact of global warming and climate change. But then the responsibility should be different also, because more responsibility should be shouldered by whom? Developed nation when compared to developing nation. When compared to developing nation. Clear? Fine. Write down. In the year 1987, Montreal Protocol was signed. In the year 1987, Montreal Protocol was signed. Montreal Protocol was signed by 27 nations. Montreal Protocol was signed by 27 nations. By 27 nations. India became a signatory to Montreal Protocol later on. India became a signatory to Montreal Protocol later on. Signatory to Montreal Protocol later on. The objective was to limit. First is to limit. Objective was to limit the production of. Objective was to limit the production of ODSs. Limit the production of ODSs. And also to phase them out. And also to phase them out. And also to phase them out. Production of ODSs and also to phase them out. And for this purpose, two time frames were set. Two time frames were set. One for the developed nation, that's shorter. One for the developed nation and second for the developing nation. One for the developed nation and second for the developing nation. Second for the developing nation. Now this would be a longer period. And we can see ODSs were classified also into different types. Write down. Under this protocol, ODSs, under this protocol, ODSs were classified also into different types. ODSs were classified also into different types. Different types. Is that clear? Now that's your Montreal Protocol. See, in the year 1990, a UN conference was organized. And this UN conference was organized to constitute a fund for helping developing nations to find alternatives for what? To help developing nations find alternatives for what? Alternatives for CFC. The alternate for CFC was found, but it was found in the form of what is called as HFCs. The alternative to CFC was found, it was found in the form of HFCs. And HFCs now was started to be used in air conditioners and refrigerators. Now the thing with HFC is what? That HFC is less damaging to ozone layer when compared to CFC. HFC is less damaging to ozone layer when compared to CFC. But the heat retention capacity of HFC is 1000 times than that of CO2. So it means that it would be aggravating global warming to a greater extent. The heat retention capacity of HFC is 1000 times than that of CO2. So this became a concern. Fine. This became a concern. And that's why we can see that Kigali Agreement was signed. The purpose is to phase out 90% of HFCs by mid of this century. 90% of HFCs by mid of this century, and if this is done, then the temperature of Earth would be reducing by what? Then the temperature of Earth would be reducing by 0.5 degrees centigrade, and this would be helpful in meeting the target of Paris Declaration. Paris Declaration. Is that clear? But Kigali Agreement is based on CBDR, Common but Differentiated Responsibility, and would be implemented in 3 phases. Let's see what are the 3 phases. In the year 1990, a UN conference was organized. A UN conference was organized. A UN conference was organized to constitute a fund. To help developing nations. Find alternates for CFC. To help developing nations find alternates to CFC. And we can see the alternate to CFC was found, but this alternate was found in the form of HFC. Right on. The alternate to CFC was found. In the form of HFC. The alternate to CFC was found in the form of HFC. Now this started to be used in air conditioners, and it was 5 to 10 times less damaging to ozone layer. Clear? When compared to the ozone depleting substances. But the concern was its high heat retention capacity. Right on. It was used in air conditioners. And was 5 to 10 times less damaging to ozone layer. Less damaging to ozone layer. When compared to CFC, you cannot say it's not damaging. It is, but it's less. When compared to CFC. But the second thing is what? That understood that it is less damaging. But the problem with HFC is what? That it is a potent greenhouse gas. Write down. But it is a potent greenhouse gas. But it is a potent greenhouse gas. Potent greenhouse gas. And the heat retention capacity of heat retention capacity of HFCs, heat retention capacity of HFCs is 1000 times than that of CO2. 1000 times than that of CO2. The heat retention capacity of water vapor is twice than that of CO2. The heat retention capacity of water vapor is twice than that of CO2. Twice than that of CO2. The heat retention capacity of methane, is 25 to 28 times than that of CO2. 25 to 28 times than that of CO2. Clear? But then all these three are short-lived pollutants in atmosphere. Write down. But all the three are short-lived pollutants in atmosphere. But all three are short-lived pollutants in atmosphere. Short-lived pollutants in atmosphere. Clear? So even though the heat retention capacity is high, they happen to be short-lived in atmosphere. They won't be persisting for a longer period of time. And one more in case of heat retention capacity, and that is what that Teflon manufacturing takes place. Teflon, you know, non-stick wares. So manufacturing of Teflon takes place. Manufacturing of Teflon takes place. Then a byproduct is released. Now this byproduct which is released is called as CHF3. CHF3, that is fluoroform. That is fluoroform. And we can see that as far as why we are discussing here, heat retention capacity of fluoroform is concerned, it is, if suppose we say that 1 ton of fluoroform, 1 ton of fluoroform is equivalent to 11,750 tons of CO2. 11,700 tons, 750 tons of CO2. So it means the highest heat retention capacity is that of CHF3, that is fluoroform, then after HFC, then after methane, and then after water vapor. Clear? Then after water vapor. Right on. You have written that the HFCs are used in air conditioners and refrigerators as an alternate for what? Alternate for CFC. Clear? CFC. But we can see that the heat, although HFCs when it is used is less damaging to ozone layer when compared to HFCs, it is 5 to 10 times less damaging to ozone layer when compared to CFCs. But the concern is what? High heat retention capacity. Clear? High heat retention capacity. That is the heat retention capacity of HFC that you have written is 1000 times than that of CO2, and everything has been depicted on the board. Heat retention capacity of HFC is 1000 times than that of CO2. So it means what? That it would be enhancing global warming to a greater extent. Right on. As such, it can enhance global warming to a greater extent. As such, it can enhance global warming on a greater extent. And you can see, you can write it down, the heat retention capacity of water vapor, twice than that of CO2, methane, 25 to 28 times than that of CO2, and also HFC is 1000 times than that of CO2, but the most dangerous is CHF3, which is called as what? Which is called as fluoroform. Right on. This we have completed. Just carry on with Kigali Agreement. Right on. Under the Kigali Agreement, under the Kigali Agreement, under the Kigali Agreement. Just 1 second. It's not Teflon, it's Teflon. Teflon. You would have seen non-stick wares. Non-stick wares. Pan, coating of Teflon is there. Press, coating of Teflon is there. Clear? Coating of Teflon is there. So when industrial manufacturing of Teflon takes place, as a byproduct, fluoroform would be released. Byproduct. And 1 ton of fluoroform, I have said, is equivalent to 11,750 tons of CO2 in heat retention capacity. So maximum heat retention capacity is for fluoroform, then followed by HFC, then followed by methane, then by water vapor. Clear? But remember that all these are short-lived in atmosphere. Although heat retention capacity is high, but they are short-lived in atmosphere. So mainly global warming would be taking place due to CO2. And as far as this is concerned, right on, that to phase out HFC, you know why it is damaging in nature, because it's HFCs are having a heat retention capacity of 1000 times than that of CO2. Right on, to phase out HFC, to phase out HFC, to phase out HFCs, Kigali Agreement was signed. Kigali Agreement was signed. And Kigali is present in Rwanda. Agreement was signed, which is considered as amendment to Montreal Protocol, which is considered as amendment to Montreal Protocol. Amendment to Montreal Protocol. Clear? So it is considered as an amendment to Montreal Protocol. And we can see, if suppose the purpose is, the objective is what? The objective is to phase out 90% of HFCs by mid of this century. Right now, the objective is to phase out. The objective is to phase out. The objective is to phase out 90% of HFCs. The objective is to phase out 90% of HFCs by mid of this century. 90% of HFCs by mid of this century. Mid of this century. 90% of HFC by mid of this century. Phase out 90% of HFC by mid of this century. And see, if this agreement is successful, then the temperature of Earth would be reducing by what? It would be reducing by 0.5 degrees centigrade, and this would be certainly conducive for meeting the target of effective, not conducive, effective in meeting the target, helpful in meeting the target of Paris Declaration. Right on. If this agreement is successful, the temperature of Earth, if this agreement is successful, the temperature of Earth, so the objective is 90% of HFCs would be phased out by 2050, mid of this century. If this agreement is successful, the temperature of Earth would reduce by, 0.5 degrees centigrade. Would reduce by 0.5 degrees centigrade. The temperature of Earth would reduce by 0.5 degrees centigrade, which would be effective in meeting the target of Paris Declaration. Which would be effective in meeting the target of Paris Declaration. Which would be effective in meeting the target of Paris Declaration. Meeting the target of Paris Declaration. Is that clear? Paris Declaration. So this is called as what? This is referred to as Kigali Agreement. Fine. And we can see that this agreement is also based on CBDR, that is common but differentiated responsibility. Now, common but differentiated responsibility means that the objective of both developed and developing nation is the same, to mitigate the adverse impact of global warming, climate change, ozone layer depletion. But the responsibility should be different. More responsibility should be shouldered by whom? Developed nation, because they were responsible for starting the fire. Clear? Right now, this agreement is based on CBDR. CBDR, that is common but differentiated responsibilities. Common but differentiated responsibilities. And why we are saying? Because if we talk about phasing out of HFCs, would be first started in 2019 by developed nation like US, Japan, under the Kigali Agreement. Fine. Then in the year 2024, 100 developing nations would do so. 100 developing nations would do so, including China. 100 developing nations would do so, including China. And then in the year 2028, we can see in the year 2028, we can see that India, Pakistan, Saudi Arabia would be starting their initiative. So it is more responsibility. First responsibility is to be shouldered by developed nation. So it is based on what? It is based on CBDR, common but differentiated responsibility. Common but differentiated responsibility. Is that clear? So this is Kigali Agreement. And one last agreement. And what is that? That in the year 2016, India was also responsible for launching an initiative for ozone layer depletion, and this initiative is called as HPMP2. HPMP2 means HCFC phasing out management plan 2. HCFC phasing out management plan 2. So that is called as HPMP2. HCFC, you know, is a ozone depleting substance. Ozone depleting substance. So HCFC phasing out management plan 2, that is called as what? Now this is referred to as the HPMP2, which was started by the purpose is to phase out HCFC 1.5 million tons, 1.8 million tons of HCFC by the year 2023, which is this year due. Right now, in the year 2016, the last initiative we are discussing, we have completed the chapter. We'll solve one test also, which has been given to you. In the year 2016, HPMP2 was launched by India. HPMP2 was launched by India. That is HCFC, that's the ozone depleting substance, phasing out management plan 2. 2 means here phase 2. HCFC phasing out management phase 2 plan 2. Clear? HCFC phasing out management plan 2. And what would be the objective? The objective is to remove 1.8 million tons of HCFC by 2023. Right down. The objective is to remove 1.8 million tons of HCFC by 2023. 1.8 million tons of HCFC by 2023. Is that clear? Now this much for ozone layer and ozone layer depletion. Ozone layer and ozone layer depletion. Now let's see last part of it. See, if in examination they ask you the sources of CFCs, at what where were the sources? See, one thing first of all, just remember that CFCs have been replaced by HCFCs. And we are talking about Kigali Agreement to phase out HFCs. So what is used in air conditioner today, you can see just above my head. HCFCs has been replaced by R32. R32 is what? R32 is difluoromethane. So HCFCs have been replaced by R32, which is called as difluoromethane. But we can use, now this is used in India, but we can use also R290, which is propane. We can also use R600A, which is isobutane. We can also use R717, which is ammonia. So all these can be used for refrigeration purpose. All these can be used for refrigeration purpose. But CFC was replaced by HFC and HFC is now replaced by R32. But possibility of using all these gases. Now as far as the sources of CFC is concerned, that what are the sources of CFC? The sources of CFC include what? ACs, refrigerators, but they are not going to ask you because they know that you know. But what are the other sources? Plastic foam, industrial solvents, plastic foam, industrial solvents, ACs, refrigerators, plastic foam, industrial solvents. So all these are the sources. Clear? All these are the sources. And also you can see sterilizer used for medical equipment. Sterilizers used for medical equipment. Medical equipment. When we talk about sources of nitrous oxide has two sources. One is vehicular emission. From vehicles, the emission which takes place consists of nitrous oxide, and second is fertilizer use. And when we talk about sources of methane includes coal mines, ruminants, the animals chewing their food, they take the food and later on they chew it, like cattle, coal mines, ruminants, paddy fields, a very patent question of PCSs, paddy fields, then water reservoir, swampy areas. So all these are the sources of methane. Now that's your complete chapter, ozone layer depletion. We have discussed almost everything. See, you can take a screenshot of the board, take a pic of, fine, that's your ozone layer and ozone layer depletion. Finished. Now, let's solve the question which has been provided to you. Look at the questions. One question has been transferred to you. So let's solve that question which has been transferred to you. Take a pic of this first of all. Fine. Now let's solve the question. So let's one by one solve these questions which See the first question. Consider the following statements and select the correct code. In the limelight of depleting ozone layer, UVB is a matter of concern, not UVA or UVC as such. Definitely, it's correct. Why? Because UVA is reaching the surface of Earth naturally. It's not a matter of concern. UVC is not at all reaching the surface of the Earth. So what is reaching the surface of the Earth in abundance due to ozone layer depletion? UVB. Energy is inversely related to wavelength. You can see that's correct. Energy is inversely related to wavelength. UVA radiation is not responsible for any damage. Yes, it is responsible for damage. For me, aging is a damage. So UVA radiation is responsible for no damage is wrong. Energy is inversely related to wavelength, that's right. And also we can see this is right, and this is wrong. So 1 and 2 would be the correct answer. Fine, 1 and 2 would be the correct answer. Now the second question. Consider the following statements and select the correct code. Can you give me the answer? First is CFCs are type of halogenated hydrocarbons which are non-flammable, non-toxic organic molecules. Second is at room temperature CFCs are gases, but under normal pressure gases under normal pressure, but they liquefy under modest pressure. See, both these statements are correct. CFCs are type of halogenated hydrocarbon, fluorocarbon, which are non-flammable. Had it been flammable, why should we have used this in air conditioner? Which is non-toxic. Definitely it's not toxic. If toxic, we would be sleeping when air conditioner is on. At room temperature, certainly it is a gas. But if suppose you are responsible for giving it a modest pressure even, from the compressor that you have, it would be liquefying. And this liquefaction process is used for cooling purpose. So this liquefaction process is used for cooling purpose, but the problem is what? That when it re-evaporates, it again would be responsible for absorbing heat. Clear? So when it re-evaporates, it would be again responsible for absorbing heat. So it's not only a greenhouse gas, it's not only a ODS but also greenhouse gas. So both the options are correct. Now tell me this one. Consider the following countries: Chile, New Zealand, Argentina and Colombia. Select the correct code of countries where UV alerts are given. Use your brain and give me the correct answer. I am drinking water and waiting for your answer. Consider the following countries: Chile, New Zealand, Argentina, Colombia. Select the correct code of countries where UV alerts are given. No answer? Anybody? Not even attempting? Now the correct answer is what? The correct answer would be B, 1, 2 and 3. Look at Colombia. Colombia is nowhere present near Antarctica. So the countries which are present near Antarctica include what? It includes Chile, New Zealand, Argentina. So 1, 2 and 3 would be the correct answer. Clear? Not 4. Very good. Very good. Very good. Very good. Not D but B. Fine. Very good. Now give me the answer to this also. Fourth question. During which period of the year ozone layer depletion would be maximum on Earth? Try this one. During which period of the year ozone layer depletion would be maximum on Earth? Just give me the correct answer for 4. Ozone layer depletion would be maximum on Earth. No answer? Option A, February, March. It's wrong. Option D, November, December, it's again wrong. Option B, June, July, it's again wrong. What is left is C only, September, October. September, October is the correct answer. Why? See, where ozone depletion takes place maximum? Ozone depletion takes place maximum in Antarctica. And it would be taking place when there is spring in Antarctica. After the winter gets over, solar radiation reaches that area. So winter in Antarctica would be getting over when? After June, July, August, September. So September, October would be the correct answer. September, October would be the correct answer. Clear? Now this one, which one of the following statement is correct about UV index? Now the correct statement you have studied, you have registered in your notes also this thing, that it is a form of daily forecast of UV exposure issued by weather service for different countries. The correct answer is D. The correct answer is D. Next question, I haven't taught you, but who among the following were awarded the Nobel Prize in Chemistry in 1995, concluding that CFCs could damage the stratospheric ozone through the release of chlorine atoms and as a result of UV radiation would increase and cause more skin cancer? It was Rowland and Molina, one from US and one from Mexico. Rowland and Molina. First. Next question. Consider the following statements and select the correct code. Major damage to ozone layer has taken place near Antarctica. There is no doubt about it. 100% correct. Ozone layer is never directly damaged by CFCs. That's also correct because CFCs happen to be inert, but when sunlight falls on CFC, they would be releasing chlorine, which is responsible for the damage. Methane is also responsible for ozone layer damage. Never. No, methane is also, yes, methane is a ODS, yes. So all the three statements are correct. All the three statements are correct. Because methane is a ODS also, methane is a greenhouse gas also. Now last one. Which one of the following UV radiation is obstructed by ozone layer? Now tell me the last one, last question. Which one of the following UV radiation is obstructed by the ozone layer? Now you have to say. Which is that? 7 you have said, C, all the three are correct. A it is. Now see. Which one of the following UV radiation is obstructed by ozone layer? It would be what? It would be UVB and UVC. UVB and UVC. Because UVB would be obstructed and UVC is never reaching the surface of the earth. It can reach the surface of earth if there is no ozone layer, but this is not going to happen because still oxygen is present and sunlight is present. Ozone would be refurbished and this would be responsible for, we can see that this would be responsible for filtering the UV radiation, harmful UV radiation as such. Now this much for ozone layer and ozone layer depletion. I think it's enough. Now from here, we start with global warming. So let's start with global warming from here. Start discussing global warming, but then only 2 or 3 minutes left. So I think that tomorrow we'll start with global warming. And after you complete this chapter, write some subjective questions. One subjective question I am giving to you, that recent reports suggest that ozone layer depletion and global warming. Recent reports suggest that ozone layer depletion and global warming are connected to each other in more than one way. are connected to each other in more than one way. Now, when you complete global warming, then you can write this. Connected to each other in more than one way. Why then? Why then? Why then? The damage to ozone layer takes place more in Antarctica. Why then? The damage to ozone layer takes place more in Antarctica. Whereas melting of polar ice is more in the Arctic region. Melting of polar ice is more in the Arctic region. So write this, get it checked from your mentors, but write it after we finish global warming so that you can have the real inputs to write. And on the other hand, we are conducting an objective test class every day. Tomorrow also we will conduct. Clear? Thank you so much. Thank you so much.